Okay, so in our last video, we solved this problem, and in this video, we're going to go over the code to make sure that we can articulate the space and time complexity. Okay, so in terms of time complexity, the input here, how do we identify the input? Well, it's basically the length of one of the strings or the length of both strings if they're the same length. If both of these strings are not the same length, then we'll short circuit, and so it kind of doesn't matter if one of the strings is longer. So we have to just assume that n is the length of one of the strings when the strings are the same length. The length function is not something that actually in Python counts over a list or a sequence or a string. It doesn't like have to check. All of those inbuilt objects just keep basically a note of how long they are so that accessing their length is O of 1. So these operations are both O of 1, so if they're not, this only counts really as one operation. So yeah, so assuming that these are basically the same length is an okay thing to do for estimating time complexity. So now sorted, that's another that's a whole nother ballgame, right? Sorting has its own space and time complexity. In Python, you don't know what sorting method this is because it's different for each data type. So in order to compare strings, you have to kind of look at what sorting function your Python implementation actually uses. Different versions use different ones. And so this is, I think it's like O of log n usually. It's better than linear, but it's not that much better than linear. Okay, so S and T being sorted, we can kind of count this as like a linear operation. It's the most simple, like mental calculation. So we can just kind of count this as like linear. And then so that's these two. So this is sort of two loops. And then as we discussed in the last video in the practice problem, this is actually another loop. String comparison is a loop. And so this is three loops, but just because it's three loops doesn't mean that it's like, O of n times n or anything. It's the number of steps grows linearly with respect to the input. In terms of space complexity, like we don't really create a whole lot of other memory. We even reuse these variables, and so during this there's a little bit of space usage, but then once these inbuilt functions exit, that space usage is deallocated, and so you're only ever really using about the size of two of these strings at the same time. And then this comparison doesn't reallocate any memory. It's just a bunch of like individual comparisons, and so really what we're doing here is also sort of linear. So we're not adding to the space here. We add to the space here like briefly. We do temporarily compare these two values, but these two values exist somewhere in memory already. So this is linear space. It's relative to S and T. And we don't use any extra memory to keep track of anything. So that's how you would evaluate this solution.